See, like suppose if you'll have two option, one a plain road and one a road with lots and lots of hurdles, which path you will choose? Plain one na? Similarly, current is also going, one he is getting resistance, one he is getting plain wire, so he'll choose the path of plain wire instead of having resistance. So what is 0? Okay, next you need to calculate Ix of 0 minus, right? Ix is over here, Ix is over here, so we can consider the current over Ix of 0 minus here. So now can you tell me Ix of 0 minus value? Simple, you can apply 3 mesh, 3 variable and 3 equation concept, right or not? Hmm? This is I1, this is I2, this is I3, right? 3 mesh, 3 variable, Ix of 0 minus is equal to I of 2. Okay, do it. So after solving I2, we'll get it as 4 ampere. Directly I'm writing down the values. You can make the 3 mesh, 3 variable and 3 equation. This one we got it as 4 ampere. Now they are asking IL of 0 minus, means at t equal to 0 minus, IL of 0 minus is this one. Yes or no? Because here it was inductor and here it was inductor. So whatever the current I3, that would be equal to IL of 0 minus only. You don't need to calculate it further because you need already calculated it. So this one you will get it as 6 ampere. Solve it in homework. I'm just telling you the hint. Okay? Understood? Now they are asking Ix of 0 plus and Ix of 0 plus. So at now we need to redraw the circuit, correct? So Ix of 0 plus, Ix is in the plain wire, right? So tell me how can we get Ix of 0 plus? So at t equal to 0, the switch is opened, right? So we need to calculate particular current for this case, right? Inductor will behave as a short circuit. Again, it's a steady state condition, right? So inductor will be short circuit. Ix of 0 plus. Now we'll have two mesh, two variable, two equation. This is I1, this is I2. So I2 is equal to Ix of 0 plus. Got it? Okay. Next you need to calculate VAB of 0 plus, means voltage across this point. Similarly you can get it this one also. Then after that you need to calculate Ix of t. Ix at t equal to infinity and VAB at t equal to infinity. So draw the circuit at t equal to infinity, then you will get the value. Last final I am telling you Ix of t at t greater than 0. How will you get it? As you know the Ix equation, for that you need to calculate tau only, right? And tau is how much? L by R, right? Tau is how much? L by R. For that you need to calculate R equivalent. Voltage source short, t equal to 0, switch is open. From these two terminal we need to calculate R, 5, 10, 60. So as you can see, current is moving like this and through the plain wire. Current will not move through this 10 and 6 ohm right now. So in this case R equivalent is only 5 ohm. L value you already know, so value you can get it. Then you can substitute in this equation. You will get the final Ix of t, IL of t. See, this is the question from your paper 2023 December. In this, two switches are there. One is 1 and another is 2. According to the switch movement, At t equal to 0, the switch is connected to position 2, right? Switch is connected to position 2. That means at t equal to 0 minus, the switch is connected to position 1, and again at t equal to 0 plus, the switch is connected to position 2 only. Now draw 3 circuit. First, again step 1 t equal to 0 minus, step 2 t equal to infinity, and step 3 t equal to 0. Draw the 3 circuit diagram. Step number 1, draw circuit at t equal to 0 minus, and capacitor will behave as a open circuit. So do it. Step number 1, t equal to 0 minus, the switch is connected to position equal to 0 minus, the switch is connected to position 1, right? Means it will behave like this. If it is not connected to 2, don't draw it, okay? One thing. And capacitor will behave as a open circuit. Marked it always at A and B terminal. So voltage across capacitor VC of 0 minus is equal to VC of 0 plus is equal to V of AB. So ultimately we need to calculate VC of 0 minus, that would be equal to VAB. Again we have to do the same procedure, like how did we calculate the voltage for the Thevenin? Same thing. Like just suppose you are standing at A, you need to move towards B. So VAB is equal to A to C, C to D, and D to B. This is 75 volt. This is 5 kilo ohm, means 5000 ohm. So again it's an open circuit, so no current will flow. This is 0, this is 0, and VCD is 75 volt. So what we got it, VAB is equal to VC of 0 minus is equal to 75 volt, right? This was our first step. Now see the steps. Draw circuit at t equal to 0 minus. If there is a capacitor, you need to open circuit it, and for that you need to calculate VC of 0 minus, correct? Now do step number 2 and show me. Now step number 2, draw circuit at t equal to infinity. So at infinity, switch is connected to 2, it must be open circuit, and as you know, if there is no supplies, so VC of infinity is how much? 0, right? VC of infinity is 0 only. Next one is you need to draw the circuit at t equal to 0 plus. Now last and final step, draw the circuit at t equal to infinity, right? So t equal to infinity, the switch is connected to position. We need to calculate t equal to infinity, that would be same position at t equal to 2, and now so in this case we need to calculate R equivalent. There is only single resistance. Let us consider 10 kilo, so that would be 10 kilo ohm. So tau is how much? R equivalent multiplied by C. R equivalent, get it? C, they have given 500 microfarad. You can get the T, and then you can finally put it in that equation. Of T is equal to VC of infinity plus V minus minus V of infinity, or minus by tau, right? This equation. Understood? Now I'm giving you one more question. This you have to it complete, then only I can that you understood properly or not. 1 second, let the diagram first. 5 1, if you will be able to do, you can do any at t equal to 0 minus, circuit is C of 0 minus, mark it A 0 minus is equal to VAB, again A to C, this is 0, this IC into 1. Mesh I1 can be, so minus 1 I plus 5 is equal, minus 2 I1 is equal to minus 5, so I1 is how much? 5 by 2 into 1, that is equal to minus, right? This is our first step. Now do the second step. At VC of infinity, the switch is not connected now, so that means there is no supply. If there is no supply, obviously VC of infinity will be 0 only. You can directly write down VC of infinity is 0, right? Next step, at t equal to 0, the capacitor will behave as a capacitor, right? Circuit will be like this, and in this you need to calculate R equivalent. Only there is a single resistance, it is 1. Tau is equal to 1 into C. C value they don't give it, so write down C only. Okay. Now in this case they gave you the VC of t, but you need to calculate the time. Do it. Put down all the values in the equation. In this case VC of t is given 1.25. Write down 1.25. VC of infinity is, you calculated 0, and VC of 0 minus is 5 by 2. 0 plus 5 by 2 minus 0, e raised to 1 minus t by tau. Tau is C only, right? So if you will solve it, this one is 2.5, e raised to 1 minus t by C is equal to 1.25, right? How will you solve it further? 1.25 divided by 2.5 is equal to e raised to power minus t by c. Then to remove e, can we take log on both sides? Because log e is 1. Log. After solving it, you will get some value, and then you will get the value of time in terms of c only. Calculate it now. See, after solving it through the calculator, do it on your homework, you will get 0.693 C. Okay, so this is the final answer.